Okay, so this is lesson 3.4. So go ahead and get your notebook in order, pause the video, and after you get your objective and your table of contents taken care of, come on back so we can start the lesson. All right, so we are going to talk a little bit about inequalities before we dive in, because we're going to be doing inequalities again today. You guys remember what inequalities are? They have these little symbols right here. Some of them have been underlined and some of them don't. So when we were doing the number line inequalities, if I had the symbol without the underline underneath it, I had an open circle. Make my pen a little different. So this guy meant I had an open circle. Because there's an underline here, that meant that I had to use a closed circle when I went to my starting point. And then of course we had to shade in the direction of the arrow. Okay? But I don't know if we really touched on what the shading means a whole lot. So I want to do that right now before we start going in today's lesson, because it's kind of relevant to what we're going to be learning next. So x is greater than 2. The reason I'm shading all of these numbers is because I can take any one of these numbers and I can plug it in for x and it will be a true statement. For example, if I plug in 3 for x, 3 is greater than 2. That's a true statement. If I take 4 and plug it in, 4 is greater than 2. If I take 5, plug it in, 5 is greater than 2. In fact, any number I plug in that's greater than 2 into this spot will make that equation a true statement. That's why we have to shade, because all of those answers are correct answers. Similarly, down here, any number that's on this side of 2 will work if I plug it into this equation here, or this inequality. But in this instance, because x is equal to 2, x is also equal to 2, I can actually also use 2 to plug in here. Up here I can't do that because 2 is not greater than 2. That's not true. But down here it says 2 is greater than or equal to 2, so I can use 2 in that particular equation. So today we're going to be doing linear inequalities, where you can see that there's shading, and you might also notice that there is some solid lines and some dashed lines with regard to actually the graph of the line. So today we're going to learn what the shading means and how to use, or when to use, a dashed line and when to use a solid line. Okay, so if I have a less than symbol, and make sure you're getting all of this information in your notes, if I have a less than symbol, I'm going to use a dotted line, and I'm going to shade below the line. Okay, so just go ahead and write this down. You'll know what it means in a few minutes. If I have a less than or equal to sign, I'm going to use a solid line, and I'm going to shade below the line as well. So whenever I have a less than sign, I'm going to shade underneath the line. So that's what that is going to look like if it's a less than symbol. And then if it's less than or equal to, of course, it will have the solid line instead of the dashed line. All right, so now we have our greater than symbols. So just the greater than is going to be a dotted line, and I'm going to shade above the line. So that's what this is going to look like. So make sure you're drawing a little image of your line and the shading so you can understand what it's talking about. Okay, so let's take a look at these two examples here. So this one was shading below the line. This one is shading above the line. That's the difference. Okay, now I have a greater than or equal to sign. You can probably figure out that it's going to have a solid line, and I'm going to shade above the line, and that's what that will look like. Okay, so solid line. So basically, here's a good way to remember it. If you have a solid line under your symbol, then your graph is going to have a solid line. If you don't have a solid line, then you're going to have the dashed line. Okay, so that's a good way to remember it. All right, take a minute, pause the video, and write down the steps for graphing inequalities before we start. All right, graphing inequalities. So this is basically going to be just like solving for y, or just like graphing lines that we learned how to do the other day, except now I have an inequality symbol involved. So there's going to have to be one more step involved. So still going to solve for y just like we've been doing. This is going to stay here. The 2y is going to stay, but I have to get rid of this 8 or negative 8x over here. So I'm going to add 8x to both sides. That will make these two things cancel. So I have 2y is less than, and let's not forget to move our x term to the front of the line because he's the important guy. He's the one that carries the slope with him. So the 8x is going to go first. And this is a negative 14, so make sure you bring that negative with the 14. All right, I still have not solved for y. I'm not done yet. I need to divide everything by 2. So I'm going to have y is less than 4x minus 7. Okay, so we're going to graph the line like normal, except I have to consider now, am I going to be using a solid line or a dashed line? Well, if you look at the symbol here, I can see that there's no line underneath it, so I'm going to be using a dashed line. So let's go ahead and fill this little chart in down here. My inequality is a less than. My line type is going to be dashed. And if I have a less than symbol, if you look at your notes on from the previous slide, if I have a less than symbol, I'm going to be shading below. Okay, so let's go ahead and graph the line. Same as before, I have a y-intercept of negative 7. 1, 2, 3, 4, 5, 6, 7. And I have a slope of positive 4. I'm going to put a 1 under that, so I have a rise and a run. All right, so I have up here from my y-intercept, I'm going 1, 2, 3, 4, up 4, and over 1. There's my next point. And I'd like to see a couple more points, so I'm going to do it again. I'm going to copy my slope again. I'm going to go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. And I think that should be enough for me to connect my dots and make a line. Okay, now keep in mind I have to have a dashed line for this guy. So I'm going to go ahead and choose my dashed line. And then let's see what I got going on here. So that is going to look something like that. And I'm going to have to clean that up because I didn't exactly hit my target. So something like that. All right. So when you are trying to figure out if you're trying which is above and which is below the line, let me get rid of all those dots. I'm going to shade. Sometimes it's a little bit hard to see what's above and what's below. So what I would suggest you do is try to imagine what's the easiest way to turn that thing so it's a horizontal line. For example, would I take the whole thing and turn it, oops, back the truck up, hold on a second. Would I take the whole thing and turn it this way to make it horizontal? Would it be faster? Or would it be easier to rotate all the way around this way to make it a horizontal line? So I'm going to say that it would be easier to go this way. So as you can see, now it's becoming more clear to me which is below the line. So this to the right area is going to be below my line. So that means, oops, that means I'm going to have to shade underneath that. So I'm going to shade this area down here. If you're not sure, you can do something. You can go to www. www.desmos.com. Okay? So go to that website and you can actually type in the equation and it will show you the shading of the graph. Okay, so I've actually gone to Desmos for you, and up in here in the right-hand corner, you can type in the equation. My y kind of got cut off here, but you can see that it's over up here in the right-hand corner. Y is less than 4x minus 7, and it very nicely drew my dashed line and showed me where to shade. So it's a really great tool that you guys should learn how to use because it's going to be on your AZ merit test, and you need to know all of its features and functions. All right, so here's the next example. So I have to solve for y again. So I'm going to box in my y. I have to then subtract 2x from both sides. That is going to leave me with 3y is greater than or equal to. Again, I'm going to move the x term in front. This is a positive 15 because there's no negative there, so I'm going to stick that at the end. All right, so last thing I need to do is divide by 3. Y is then greater than negative 2/3 x plus 5. All right, let's go over here and graph our line. I've got a y-intercept of positive 5. That's on the y-axis. 1, 2, 3, 4, 5. So here's my y-intercept. And then I have a slope of negative 2/3. So this negative means I'm going down. That positive 3 means I'm going right. So down 2 over 3. And again, down 2 over 3. Down 2 over 3. Okay? Am I going to use, now we have to be careful before we draw our line. We have to go back and look at our inequality symbol because this is important. This example has an underline underneath it, which we learned in our notes previous that means I use a solid line. All right, and because it says greater than, I am going to shade above the line. So this one's a little bit easier to tell which one's above and below. Above is up here. In fact, above, a way you can tell if it's above is if you can draw a line away from the line and it's going uphill, then it's above the line. If you draw a line away from a line and it's going downhill, then it's below the line. So that's a good way to tell if it's above or below. Or you can always go back to Desmos and type in the inequality and see where the shading belongs. All right, 8x plus 4y is greater than or equal to 24. Go ahead and try that example on your own. All right, so I came up with y is greater than negative 2x plus 6, and I went to Desmos and put in the equation, and that's the results that I got. So check my results with yours and make sure you did it correctly. All right, this one's going to be a little bit different, not much, because we're going to bring back some previous information that we learned. So pretty much going to start out the same. The y term is going to get boxed in. Make sure you're bringing that negative with that because that's really super important. It has to stay with it. All right, so I'm going to add 2x to both sides. That's going to make those two x's cancel out. Bring down the negative 5y and put your x term out front. And your plus 20 at the end. Okay, so here's where it's going to get a little different. Do you recall what happens when I divide by a negative number when I'm using an inequality symbol? If you remember correctly, when I'm dividing by a negative, the inequality symbol has to change to the other direction. I have to flip the sign. So this is going to actually end up being y is less than or equal to, because I have to flip the sign, negative 2/5 x minus 4. All right, so I know I'm going to have a solid line when I plot my graph because I have the underline under my inequality symbol. So my y-intercept is -4, so I start there at -4. Then I have to use my slope of -2/5. So down 2 over 1, 2, 3, 4, 5. And I'm going to do one the other direction just so I can have it on the other side of my y-axis. Up 2 over 5. Okay, so that gives me a nice line that looks something like this. Make sure you're drawing arrows on the ends of your line because it is infinite in both directions. All right, now I need to figure out where my shading is. My shading is less than, which means it's going to be below the line. So my shading is all down here, below the line. All right, go ahead and try that one on your own and then come on back to see if you did it correctly. All right, go ahead and check your work. Maybe the thing you struggled with the most was trying to figure out what to do when there was no number in front of that x, so make sure that you notice that I added a 1 in front of there, which made it easier for me to add and subtract it across the inequality sign. And then don't forget, when you divided by this -2, that meant you had to flip your sign the other direction, which made it less than. Okay, let's go on to the next example. All right, the next section involves inequalities of horizontal and vertical lines. If you remember the other day, we talked about Hoy and Vux. So Hoy, H-O-Y, actually in this case it's H0Y. Hoy stands for horizontal line, has a 0 slope, and it has an equation that looks like y equals something. So this equation, let's do it, maybe this is the way you can remember it. Since this has a y in it, I know it's going to be Hoy. And then I'm going to take this number and put it over here. All right, so here's my equation. This tells me I have a horizontal line with a 0 slope, and my equation is going to be, I'm going to have a point, I'm going to have a horizontal line going through the y-axis at -6. 1, 2, 3, 4, 5, 6. So I have a horizontal line going through the y-axis at -6. All right, same thing. This is a Hoy because of the y in it. So I'm going to have a horizontal line going through the y-axis at +4. So there's my graph. Oops, hold on. I forgot something, didn't I? I forgot about the inequality. Sorry about that. All right, so I have my line down here. I'm going back to this example. Y is greater than or equal to -6. So greater than or equal to means that I have a solid line and I have to shade above the line. So that's clearly, you can see very easily which side you have to shade on that one. All right, let's go to this guy because I did this one a little bit incorrectly. I wasn't paying attention. Okay, so I have y is less than 4, so we have the horizontal line here going through the y-axis at +4, except I don't have to have, I should not have a solid line here. My line should be dashed because it's a less than and not a less than or equal to. All right, so now I have y is less than 4. Less than means I shade below the line. So that was pretty easy to see how to do that. All right, this is a Vux, right? Because it has an x. So x is greater than or equal to 6. So Vux stands for vertical, undefined slope, and the equation is going to have x equals or x with an inequality symbol. So this one's going to go through the x-axis at 6. 1, 2, 3, 4, 5, 6. And I'm going to have a solid line. So a solid line going through the x-axis at 6. but I still have to shade. So when you have a vertical line, you can't really shade above or below. You can only shade left or right on either left side or the right side of the line. So I'm thinking if you gave it a little thought and noticed that this was x is greater than 6, that means all of the numbers that are greater than 6 are on this side of the line. So that's where the shading should be. All right, x greater than 4. Let's make that a negative 4, since the other one was a positive one. All right, so x is greater than negative 4. So here's my point on the x-axis at negative 4, except because I have to have now a dotted line going through there. And again, it's greater than, so I'm going to be shading to the right. Okay. So I want you to, in your notebook, come up with 3 things, 3 key terms that you need to remember, and write them down in your notes. And when you're done, I want you to raise your hand so that I can come over and check it and make sure that you took proper notes and wrote down your 3 things, and then you will be able to start on your homework. Thanks for watching, and we'll see you next period.